In this video, we will be learning how to solve one-step inequalities that use either multiplication or division. First, though, we're going to look at something kind of weird that happens when we're multiplying and dividing on both sides. So we're just starting with something we know. 7 is greater than 4. That is a true statement. We also know that when we're solving equations, we can multiply by the same thing on both sides, and it keeps the equation the same. In inequalities, though, something weird happens. So let's actually look at what happens if I multiply both sides of this inequality by -1. So I'm allowed to multiply both sides by the same thing. On the left, we get -7. On the right, we get -4. Here's the thing though, if I keep this symbol the same, then I actually get something that is false. -7 is not greater than -4. So in order to fix this, I actually need to reverse or flip my inequality symbol. That's the only way that this statement will be true, because -7 is actually smaller than -4. So now, after I flipped that inequality, I get a statement that is true. So that brings us to a rule that we're going to keep in mind anytime we're multiplying or dividing by a negative. The same process would work if I had divided by -1 on both sides instead of multiplying by -1. So this is a rule you need to have down. When multiplying or dividing by a negative, you must flip the inequality symbol. Okay, and that's only if the thing that you are putting on both sides to multiply or divide by is negative. So let's kind of distinguish between a couple different situations. A common error, it says a negative sign in an inequality does not necessarily or not always mean you must reverse the inequality symbol. Only reverse the inequality symbol when you multiply or divide both sides by a negative number. So we're going to look at when we flip it and when we don't. I'm going to start with this one right here. To solve this inequality, I would be adding 3 to both sides. And I never multiplied or divided by a negative, so I do not need to flip the inequality for that one. Okay, let's also move on to the one with subtraction. To solve this, I would add 3 to both sides. Again, I'm not multiplying or dividing by a negative, so I do not need to flip the inequality symbol. Okay, let's look at this one right here. So to solve, I need to divide by 3 on both sides. Now, this number is a negative, but that doesn't matter. We don't care about that one. We only care about this one that's actually being multiplied or divided on both sides. So this number right here, that's the one we care about. Because that number is positive, we do not need to flip the inequality symbol. Okay, let's move on to this one. Over here, to solve that, I would actually need to divide both sides by -3 in order to cancel out the coefficient of -3 on the term -3x. Now I'm dividing both sides by a negative, so this is a situation where I do need to flip the inequality symbol. Okay, so again, it's okay if there are negatives in there. That doesn't automatically mean you're going to flip it, but it's when you are dividing both sides or multiplying both sides by a negative that you would then need to flip your inequality. Okay, let's work through a few examples. So we're starting with the inequality x divided by 5 is less than or equal to -3. So to undo dividing by 5, we need to multiply both sides by 5. So on the left-hand side, that's going to simplify down just to 1x. On the right-hand side, I'm going to get -15, and the number that I multiplied by was +5, so I do not need to flip my inequality, and it's just going to stay x is less than or equal to -15. So we can put -15 kind of in the middle, And then we can count out negative 16, negative 17 to the left, and then to the right, negative 14, negative 13. The less than or equal symbol tells us to use a closed circle. So we'll fill that in. And it's going to shade in all the numbers that are less than or equal to negative 15. So that means it's going to go to the left, and we'll put an arrow on the end to show that it keeps going in that direction. All right, next we have the inequality 6x is greater than negative 18. To solve that inequality, we need to divide both sides by 6. So we'll get x is greater than negative 3. Again, I'm dividing by a positive number. There's no need to flip the sign. So we can put negative 3 kind of in the middle. We'll count out negative 4, negative 5. The other direction, negative 2, negative 1. This time we're going to use an open circle at negative 3. And we want it to go to all the numbers that are greater than negative 3. So that means it's going to go to the right, and we'll put an arrow going in that direction. For the inequality, negative 3z is greater than negative 4.5. We will need to divide by the coefficient on both sides, which is negative 3. So this is the first time we see an example where we are multiplying or dividing by a negative on both sides. So this will be a time where we need to flip the inequality. Okay, on the left-hand side, negative 3 divided by negative 3 is just 1, so we get 1z. On the right-hand side, negative divided by a negative is a positive. If I do 4.5 divided by 3, this is what that division would look like, and then decimal will move directly above, and I'm going to get positive 1 and 5/10. Now, because we divided by a negative number instead of using the greater than symbol, we're now going to use the less than symbol. Okay, and we had to flip it based on what we saw back at the beginning, where it was no longer a true statement if we didn't flip the sign. So we're going to graph the inequality z is less than 1 and 5/10. So I could count by, maybe I'll count by 5/10. You could also count by 1/10 if you want. So I'll do 1.5, 2, 2.5, and then going the other direction, 1, 0.5, 0. And I'm skipping lines when I'm numbering just to give myself a little bit more space. Okay, this is going to be an open circle at 1 and 5/10. And since z is less than that amount, we're going to shade to the left right here. Next example, we have negative 3 halves n is less than or equal to 6. Just like when we were solving equations, if we want to undo multiplying by a fraction, we're going to multiply both sides by the reciprocal. So I'm going to flip this and make it negative 2/3. And I'm going to multiply by negative 2/3 on both sides. So on the left-hand side, this would become 6 over 6, which is just 1. So I get 1n. And then on the other side, right-hand side, I'm going to get negative 12/3, which is the same as negative 4. And because I multiplied both sides by a negative, I'm going to flip my inequality. Instead of less than or equal, I'm going to use greater than or equal. So I get n is greater than or equal to negative 4. So we'll number negative 4, negative 5, negative 6, negative 3, negative 2. This will be a closed circle, and we will have our line or array go to the right. So n is greater than or equal to negative 4. Okay, moving on to some word problems. It says you earn $9.20 per hour at your summer job. Write and solve an inequality that represents the number of hours you need to work in order to buy a smartphone that costs $299. So let's look for our variable. Write and solve an inequality that represents the number of hours. So we can say maybe H represents number of hours that you need to work. Okay, because you make $9.20 per hour, that means you're going to multiply $9.20 times the number of hours. Okay, we need to kind of think this through. If you're buying a smartphone that costs $299, and maybe we're assuming that that includes taxes and fees and all of that, in theory, we could make exactly $299. We couldn't have less than that, but we could have more than that. So that means that we're going to use the inequality greater than or equal to 299 because we need to have at least $299. Okay, now to solve this inequality, we are going to divide by $9.20 on both sides. So on the left-hand side, we would just get H, and then we need to do division. So here's what that would look like. 299 would go inside the division box, and I can just make this 9 and 2/10. That's the same as 9.20. We need to make sure the number we're dividing by on the outside is a whole number, so I'm going to multiply times 10 times 10. That's going to add a 0 on the end here. So this is the same as doing 2,990 divided by 92. And here's what those steps will look like. All right, I cut out all those steps just to speed it up a little bit, but everything is color-coded so you can see exactly where that came from. So the number of hours that you would need to work would need to be at least 32.5. And we're going to keep the same symbol. So hours is greater than or equal to 32.5. And we'll put units of hours. So if you're working full-time, that's almost a full work week at 40 hours per week. Okay, next, you have $9.60 to buy avocados for a guacamole recipe. Avocados cost $2.40 each. Write and solve an inequality that represents the number of avocados you can buy. So write and solve an inequality that represents, that is going to be our variable. So I'm going to use A for number of avocados. Okay, because each one is $2.40 each, we're going to do $2.40 multiplied by the number of avocados. We only have $9.60, so that amount could be equal to $9.40, but it could not be larger. So 2.4a needs to be less than or equal to $9.40. When we solve this inequality, we need to divide by $2.40 on each side. So the left-hand side, we would just be left with A. We're not going to need to flip the inequality, and now we just need to do division. So I'm going to do $9.40 divided by $2.40. And I can actually just multiply both of these by 10 and not worry about that extra 0. So 94 divided by 24 is what we actually need to figure out. So when I do 94 divided by 24, I'm going to try 4. 4 times 4, that would actually be 96. So I'm going to go down 1 and try 3. So 24 times 3 would be 72. Then I can subtract. And I'll need to add an extra decimal with a 0. And I can bring down the 0 and figure out how many times 24 goes into 220. We'll also put decimal right there in the answer. 24 goes into 220 9 times, with 4 left over. And we're going to get a decimal. Here's the thing though, we can't buy parts of an avocado. So even though 3.9, whatever it ends up being, would actually mathematically round up to 4, we don't have enough money for that. So I'm just going to say that the number of avocados that we can buy is actually less than or equal to 3. And then we'll put units on it. And it doesn't really matter what the rest of the decimals are. The 3 avocados would be the maximum number that we can get. Okay, final example is a geometry example. Write and solve an inequality that represents x. It tells us the area. The area formula for a rectangle is just going to be length times width. So to find area of that, I would do 10 times x. And it says that that amount needs to be greater than or equal to 120 centimeters squared. So we can divide both sides by 10, and that's going to leave us with x is greater than or equal to 12. That represents this side length right here, and the units on that are just going to be regular centimeters because it represents a side length. Okay, main idea for this set of video notes. Steps are going to be the same as they are for solving one-step equations. The only thing you need to make sure you do in addition to that is flip the inequality symbol if you're multiplying or dividing by a negative number. All right, thank you for watching.